Okay, so we'll go back to another video. So it's been a while since we last covered a number comparison video. So we have two numbers in forms of, cube radicals. So which is bigger, the cube root of 212 or 3 plus the cube root of 26? So again, just like any number comparison, let's actually go to the restriction and say we are not allowed to use any sort of, devices / calculators to compare the two numbers, because that would be too easy. So if we want to tackle such analysis on comparing which numbers are which of these two numbers are bigger, then we actually want to, in this strategy, we actually want to set a nice little sort of generalization. But before we actually get to that sort of generalization, we actually want to rewrite these numbers a little bit differently so that we can actually set that to some variable we want to call that equal to, and then we can actually make a little bit of the expression we can actually, come up with / define, then reducing that expression down such that it's actually going to make, the analyzing the behavior of the number what it really is, whether that be positive or negative, that sort of thing. So that'd be a little bit easier to, work around with. So nothing needs to be said. So you're actually going to notice that since this is a cube root of 3, I think one of the first things we should do is actually take the cube root of that just to eliminate that sort of radical, symbol, the radical function itself. Then we can actually just make things a little bit easier just from that substitution first, actually after that whole, expansion of the generalization. So I'm saying too much, so why don't we actually just jump right in? So it's worth noting that the cube root of 212, what we can actually rewrite this as is going to be the cube root of 4 times 53, and then what we can do is break up 53 such that it's actually written as a sum, so 4 times 27 plus 26, right? And so 3 plus the square root or the cube root of 26, I can actually write that such that 3 it can be written as the same thing as the cube root of 27. So the cube root of 27 plus the cube root of 26. So what we have is that now let's actually suppose that let's set x equals 27 and y equals 26. And so with that being the case, now we can actually sort of define our two numbers in the worlds of, variables of x and y. So what we'll do is let's now call two numbers a and b. So let's first call capital A. So let a equals the square root, or I keep saying square root, the cube root of 4 times x plus y. So essentially, we're going to let a be this number over here after we take away the 27 and 26 from, calling those variables. And then we'll actually let b, set that equal to the cube root of x and then plus the cube root of y. And so another analysis to see is that we want to observe that for both a and b, well, it's after we actually just plug in y and x back into the variable. So those two numbers, essentially, we can now already tell that both of those numbers is actually going to be, of course, strictly greater than 0. So those are indeed going to be positive numbers. And then next what I'll do is let's actually take the difference of a cubed minus b cubed. This is just so that the a cubed minus b cubed is just going to help us eliminate, the radical symbol from over here. And what we have is that this is actually going to be 4 and then times x plus y. And then now it's going to be subtract. So inside this quantity, we actually, take the cubic binomial of this function over here, which says that a plus b quantity cube is going to be equal to a cubed plus 3a squared b plus 3ab squared and then plus b cubed. So we actually just substitute that formula and then x and y, just plug that back in. And then I actually just, factor out one of the terms specifically, so x plus y. And then we factor out this term specifically over here, so plus 3 times xy quantity 1 over 3. I'm going to write the exponent in terms of a rational number, and then multiply by x 1 over 3 plus y 1 over 3 like this. Okay, so now as you notice that there's actually some things we can actually simplify. For one, that I have a x plus y and an x plus y here, so that quantity can definitely be reduced down. So going forward, we have is now in terms of 3, and we have everything 3's here, so that also can be factored out as well. So now 3, then multiply is going to be x plus y, and then multiply, or rather subtract since I factored that out, so minus xy to the power of 1 over 3, and then multiply by x 1 over 3, and then plus y 1 over 3. Okay, so with this, and then what I'm gonna do here, this is actually gonna be a nice little trick because the next step after performing that is we're actually gonna factor out another term. So what I'm gonna do is I'm actually gonna go back to what we have originally for x plus y. So basically this was taking the x to the power 1 over 3 plus y to the power 1 over 3 and then cube that. And then we're actually gonna like add a 0 term to it. So because what that does is that, so let me first write out what we do. So first it's gonna be 3 and then multiply by x 1 over 3 plus y 1 over 3 quantity cube, and then subtract 3 times xy quantity 1 over 3 multiply by x to the power 1 over 3 plus y 1 over 3, and then subtract, so x, y, and then 1 over 3 multiply by x to the power 1 over 3 plus y 1 over 3. Okay, close that off. Since if we actually put that expansion and subtract this term, we actually just get the exact same thing from before. And then from here, what I can do is we'll actually factor out this term, the x to the power 1 over 3 plus y 1 over 3. So this is going to be equal, so 3. So factor out the x 1 over 3 plus y 1 over 3. Then inside what we have is that this is going to be so x to the power 1 over 3 plus y to the power 1 over 3 quantity square, and then subtract, so we actually just combine some like terms, of course. So this is going to be times 4, and then minus 4 times xy to the power 1 over 3. And then, well, if I want to expand this even further, I can actually just write this as x 1 over 3 and then y 1 over 3. That's another option if you want to do that, but that's what I wrote down, so we're just gonna keep it that way. And so you can actually see from this term over here that we can actually, you know, unfoil that. So we actually get something in terms of quantity square. So the x to the power 1 over 3 plus y 1 over 3, that still stays the same. So what we have is, so that is fine the way it is. So once you unfoil this term over here, we get that this is the following. It's actually going to be in terms of a difference. So 1 over 3, so x to the power 1 over 3 minus 1 to the, or y to the power 1 over 3, then quantity square. All right, so we're back to here, and that's actually as good as it gets that we can actually reduce this down to. So now let's suppose that we actually, I wouldn't really say suppose, so now let's next put back our terms x equals 27 and y equals 26. So of course I have 3 multiplied by 27 to the power 1 over 3. I'm just gonna write the exponents the way it is instead of in the terms of radical symbol, plus 26 1 over 3, then multiply, so 27 1 over 3 minus 26 1 over 3, and then quantity square. Okay. So 27 1 over 3 plus 26 1 over 3, that's basically the same thing as this, which going back to that formula, this is going to be capital B, which we established that of course this is actually going to be strictly greater than B. We can already notice since this is 3, that's a positive number, but cube root of 26, that doesn't actually equal to like a integer, but we know that it's actually going to be less than 3, but it's also going to be greater than 2 since the cube root of 8 is going to equal 2, so it's in between that range. So we know that's a positive number, therefore this itself is a positive number when you put 27 and 26 back. So this over here is going to be greater than 0, and then over here, this is 27 and then minus 26. Again, you use that similar argument, so you're basically subtracting, but of course this is still going to result in greater than 0. But let's say, even if you didn't know this, but because we know that we have a quantity square, and of course with that being the case, square functions are always, you know, going to be, you know, positive. When you square a number, it's always going to be a positive number. So therefore, this entire thing is indeed strictly going to be greater than 0. So therefore, the establishment we have is that a cubed minus b cubed is strictly greater than 0. And then if you actually do some algebra with inequalities, we have that a cubed is strictly greater than b cubed, and then lead to the establishment to say that a is indeed strictly greater than b, which therefore going back to the formula, a over here, if you plug back the numbers, so 27 and 26 for x and y, we have that therefore that the cube root of 212 is indeed going to be bigger than 3 plus the cube root of 26. And so therefore that concludes it. So our bigger number is that it's 212, the cube root of 212 is indeed going to be bigger, than 3 plus the cube root of 26, just like that. From everything we just, you know, established and utilized the inequalities over here from observing what the numbers are going to look like. So yeah, that's pretty cool if you ask me.